Okay. Hi, student. Hi, teacher. Uh, Good afternoon. My name is Alejandro, and today I will be present about the mechanical properties of materials, which are a fundamental topic in civil engineering. Okay. Uh, the properties help engineers understand how materials behave when forces, as tension, compression, or shear are applied to them. Yes. In this presentation, I will explain the main mechanical properties of materials and their importance in construction and structural design. Okay, entonces, the first mechanical property of materials, a fundamental concept in civil engineering and structural design. Mechanical properties describe how materials behave when subject to forces, tension, compression, bending, or impact. Understand the properties is essential for designing safe structures that can withstand load and environmental conditions. Okay, two. What are mechanical properties? Mechanical properties refer to behavior of material under applied force. When a load is applied, materials may deform, stretch, compress, bend, or fracture. The direction depends on internal structure and composition. For example, metals like steel deform before breaking, while glass fractures suddenly. Engineers study these properties to predict performance and select appropriate materials for each structure. Which material should be used for a specific structure, steel or glass? Steel deform before breaking, sweet tables for structures requiring flexibility, and glass fractures suddenly, ideal for application where sudden failure is acceptable. Okay, continue. In the materials, um, uh, stress and strain, two fundamental concepts understand material behavior. One, stress, force applied per unit area ensures internal force distribution within a material wind load. Strain, deformed relief to original size, occurs when material is stretched. Okay? Allí, stress measures the international force per unit area, indicating how force are distributed. Strain represents the deformation relief to the original size, showing how the materials. Strain straight curve visual the resonance between stress and strain, helping predict materials behavior. Okay, continue. Types of material properties. Several important properties engineers must consider. Mechanical properties of material. 1. Strength. Resistance to deformation under load. Electricity. Ability to return original shape after load removal. Plasticity. Performance deformation under load. Hardness. Resistance to scratching and indentation. Toughness. Ability to absorb energy before fracturing. Ductility, ability to deform with factory. Bendis, um, tendency to fracture with lip deformation. Okay. 7, mechanical properties. Um, Next, what? Stretch. The ability of the material to withstand applied force with failure. Different types exist based on force type. For example, tensile strength resists force that strains the material. Compressive strength resists force that compress the material. Shear strength that resists slipping between material layers. In civil engineering, steel and concrete are their strength properties. Okay? Tensile strength resistant to extrinsic force. Compressive strength resistant for compression force. Shear strength resistant to sliding force. Civil engineer application selection of materials based on stretch. Okay? Next. Okay. Elasticity. Okay? The ability of a material to return to its original shape after force removal. Elastic deformation is temporary. Key characteristics: temporary deformation under load. Material returns to initial shape when load disperses, prevents permanent damage. Engineering importance: buildings and bricks constantly experience load from wind, traffic, and earthquakes. Elastic material allows the structure to deform slick under load with permanent. Under storm, elastic. The mesh prevention prevents permanent damage from external force. Temporary deformation: the material is deformed but not permanently. Original shape recovery: the material returns to its initial form. Structural importance: crucial for buildings and bricks to withstand loads. Okay, continue. Next. Okay, Hooke's law. The concept of elasticity is closely related to Hooke's law. This fundamental principle states that deformation is proportional to applied force, as long as the material remains within its elastic limit. Stress is proportional to strain during elastic deformation. Hooke's law is fundamental for understanding structural response to loads and is widely used in structural analysis. Okay, entonces, elasticity, the ability of a material to return to its original shape after deformation. Proportionally, the degree relationship between force and deformation. Stress, the force applied per unit area of material. Strain, the measure of deformation relative to its original size. Elasticity limited, the maximum stress of material can stand before permanent. Structural analysis: the process of evaluation how structures respond to loads. Okay. Next. Okay. Plasticity: the ability of the material to undergo permanent deformation without breaking. Unlike elastic deformation, plastic deformation remains after removal. Load removal. Material process: important in metal forming, bending, and shaping operation. Structural benefit: allow visible sinks of the before collapse. Common materials: steel and aluminum experience significant plastic deformation. Industrial plastic: permanent deformation. The material retains its new shape after load. Materials some steel and aluminum. Its significant is plastic. Engineering process used in metal forming being and shape. Structural benefits allow structures to show distress before collapse. Okay, next, continue. Hardness. The ability of a material to resist surface deformation, scratching, or in the nature hard materials are more resistant to wear and abrasion. Friction-resistant components experience friction or repeat contact. Pavements, developed all materials with raw surface. Floors, construction floor materials. Equipment, construction equipment components. Yes? How do hardness affect selection in civil engineering? Hardness ensures durability and resistance to wear, surface for pavement and flooring. Loop hardness may lead to faster wear of the fur, less ideal for high friction areas. Toughness, the ability of the materials to absorb energy and deform before fracturing. It represents a combination of strength and ductility. Impact resistance withstands sudden loads without breaking. Seismic zones section from earthquake-prone areas. Dynamic loads structures exposed to varied force. Structure style is considered too big because it cut about amount of energy before fracturing. Okay? Toughness in materials. 1. Ductility. 2. Strength. 3. Toughness. Okay? Um, Continue. Next. Okay, it's perfect. Ductility. Ductility is ability of a material to deform significant under tension, stress before breaking. Highly ductile materials can be shed into long shape without fracturing. Steel being the classic example. This property is critical in civil engineering because ductile materials provide visible warning signs before failure through notice blade deformation, allowing engineers to detect structural problems before catastrophic collapse occurs. Yes, definition: ability to deform significantly under tensile stress. Characteristics can be stretched into long shape without fracturing. Example: steel, a classic example ductile in material. Importance: in civil engineering, predict warning before failure be showing visible deformation. Benefit: allow engineers to detect structural problems before catastrophic collapse. Okay, continue next. Brittleness. Brittleness represents the opposite of ductility. Brittle material structure suddenly with little or no visible deformation, making them potentially dangerous in structural applications. Brittle materials glass, ceramic, and some concrete types. Solvent failure. It wearing before fracture. Solution: reinforcing steel adds ductility. How to manage brittle in structural application? Brittle materials fracture soundly with little deformation. Ductile materials deform before fracturing. Okay? is a perfect continue. Next. Okay, next. Mechanical properties in construction materials. Different construction materials exhibit distinct mechanical properties that determine their application in civil engineering projects. Concrete, excellent compressive strength but relatively low tensile strength. Steel, very high tensile strength and excellent ductility. Aluminum, lighter than steel with low strength and corrosion resistant. Composites combine multiple beneficial properties for special applications. Yes. Mechanical properties of construction materials. Composite materials combines multiple beneficial properties. Concrete, excellent compressive strength, low tensile strength. Steel, high tensile strength, excellent ductility. Aluminum, lightweight, good strength, corrosion, and resistance. Okay, steel in civil engineering. Steel stands as one of the most important materials in civil engineering due to its exceptional combination of high strength, high ductility, and excellent touch. Yes, structural elements, beams, columns, rights, and reinforcement bars. Load capacity capable of supporting large loads efficiently. Dynamic resistance provides flexibility and resistance to dynamic force. Choose the appropriate materials for structural elements, steel, high strength, ductility, and tough, or other materials may lack essential properties. Okay, next, continue. Concrete behavior. Concrete represents another essential construction material with very high compressed strength, making it ideal for columns, foundation, and load-bearing walls. However, concrete is weak in tension. Okay, concrete, high compressive strength, steel bars, high tensile strength. Reinforced concrete commonly benefits it. Engineers use reinforced concrete and bearing steel reformed with the concrete to create a composite material to leverage compressive strength of concrete and the tensile strength. How to optimize concrete structural performance? Compressive strength is ideal for low-bearing structures. Tensile strength with attention requires reinforcement. Okay, okay. Next, okay. Important in structural design, understand. Understanding mechanical properties is essential for safe structural design. Engineers must consider how materials will behave under different types of loads, including static loads, dynamic loads, and environmental effects. Yes. 1. Material selection. Choose appropriate materials based on properties. Load analysis. Evaluate static, dynamic, and environmental loads. Structural safety. Ensure reliability and to prevent failures. Efficiency. Optimize cost and performance. Unveiling the role of mechanical property design. Mechanical properties understand material behave under various conditions: safety, durability, and efficiency. Yes? Okay, continue. Conclusion. Mechanical properties play a crucial role in the engineering and construction determine how materials respond to force, how they deform, and how they ultimately fail. Yes? 1. Strength is resist applied force in structure. 2. Elasticity, the return to original shape. Okay? And 3. Ductility, the force before breaking structure. 4. Toughness resist fracture in structure. Hardness resist denudation in structure. Okay? For civil engineers, understand these properties is essential for design safe, durable, and efficient structure selection. The materials ensure structural safety, durability, and efficiency. Without this knowledge, it will impossible to discern reliability. Okay. Thanks for your attention, teacher and students. Bye bye.